Polyatomic compounds. In this lesson, we're talking about polyatomic compounds, naming, formulas, exceptions, and multivalence. Let's get started. Polyatomic compounds. Polyatomic compounds are groups of atoms that can be found as parts of a molecule. These atoms bond in such a way that they have a net electric charge, usually negative. So this is what makes them different from ionic compounds. So polyatomic compounds are not the same as ionic compounds. The resulting group of atoms is an ion, therefore it can form a bond. Here are some of the most common polyatomic compounds, and we can see them right here below. So what happens in terms of polyatomic compounds and ionic compounds is that they are different. You can see that, for instance, this guy right here, this sulfate, is HSO3 negative, so it has a charge. Chlorate is ClO3 negative, so it is charged. So it is not an ionic compound. What would make it an ionic compound is if we were to bring something else in, like sodium. So sodium has a charge of +1, and if we were to bring chlorate nearby, they would bond. And we'll see how they're going to bond in a second. But what they would form is NaClO3. And that would be the resulting molecule. This would be the ionic compound. First up, let's take a look at naming polyatomic compounds. So the first thing we're going to do is write the name of the metal, including the Roman numeral if necessary. Then we're going to write the name of the polyatomic. And note, for a polyatomic, you do not need to change the ending of the molecule to "-ide. So that's going to be very important as well. Check your understanding. Name the following polyatomic compounds. So in this case, we're simply going to be left with the name. So I want you to pause the video, and I want you to answer these 3 questions. Okay, so let's take a look at the first one. So what we need to do is break it into its 2 different components. So the first one here is going to be calcium, and the second part is going to be phosphate. So once we do that, we just simply write it out as is. So we say calcium, phosphate, and that's our answer. The second one here is going to be copper, and this one here is sulfate. And we can recognize that by going back to our polyatomic chart, and sulfate is right here on the bottom, SO42 negative. So if it's SO42 negative, that means it had a charge of -2. So now what we need to do is the part's a little bit tricky. This is going back to the previous lesson when we needed to do the reverse and crisscross rule. So in this case right here, we're going to put a bracket around it just for simplicity's sake. And we're going to say, okay, there's a 1 down here, and there's a 1 down there. And this 1 beside the SO4 is representative of the SO4 in its entirety. So that's one thing you need to keep in mind. We're going to bring the 1 up here, and we're going to say +1. We're going to take the 1 here, and we're going to move it here, and we're going to say -1. But then we're going to take a look at our chart, and we're going to check. Sulfate is SO4 2 negative. So this should actually be -2. So how do we make -1 into -2? We multiply it by 2. What we do to the right side, we do to the left. So we get copper 2 sulfate. And the third one, this is pretty basic. There's no multivalence. It's just going to be beryllium carbonate. And we can find carbonate by looking at our chart here, and it's right there. CO3 2 negative. Now some exceptions. You may have noticed that they're all negative except ammonium, which is NH4+. And that's really the only common positive polyatomic ion. Ammonium will form ionic compounds with nonmetals. So all the other ones, all these negatives are going to form with positives. Ammonium is a positive, so it will form with a negative. So to name these compounds, we write the name of the polyatomic, and then we write the name of the nonmetal, changing the ending to "-ide. So this is where it gets different. So in this case, we're going to name the polyatomic normal. So it's going to be ammonium. But then the second one, the negatively charged ion, that's when we're going to go back and change it to "-ide, just like we did previously with our ionic compounds. Check your understanding. So I want you to pause the video and answer these 3 questions. Then we'll resume and we'll take them up. Okay, so for the first one, this is simply ammonium. So there's no compound here, it's just ammonium polyatomic. For the second one, it's also ammonium. So we just write ammonium. But then the second element is going to be chlorine. So since it's a negative, we're going to change it to "-ide. So the answer is ammonium chloride. The third one, ammonium again. And the second element involved is oxygen, so it becomes oxide. So similar to naming previously, but now we're having ammonium in there. Check your understanding. Now I want you to give the chemical formula for the following compounds. So I want you to pause the video and answer these 4 questions. Okay, so let's take these 4 up. So for the first one, manganese 2 sulfide. So we're just going to write the symbols out, Mn and S. We know the charge on manganese is 2. So when it gets crossed over, it goes down here to the sulfur underneath for 2. The charge on sulfur we know is 2 negative because we find that on the periodic table, so it would come down here. So our resulting molecule would be Mn2S2, and then we need to bring it to lowest terms, and it's just MnS, and that would be our final answer. For the second one, tin 2 fluoride. So the symbol for tin is Sn, and the symbol for fluorine is F. We're going to write the charges above. Tin we know is 4, because it says it right there. And fluorine, we look at the periodic table, and we know it's 1 minus. And then we're going to cross them. And what we're going to be left with is SN1F4, and that's our final answer. Let's take a look at the third one. It's a little bit more complicated. The first one, copper, is just normal. It's just copper. We know it has a charge of +2 because it says it in the Roman numerals. But the second one is phosphate. So we need to see what the formula for phosphate is. So let's take a look at our polyatomic chart. So looking at our polyatomic chart, we can find it right here. It's PO4, 3 negative. So let's write it out. PO4, 3 minus. And now we're going to cross them just like we did before. The 2 comes out there, and the 3 comes out there. And then we're going to rewrite. We're going to say Cu3, and then we're going to put brackets around, because when you have a polyatomic with a subscript, you put brackets around it. So we say PO4, 2. And that's our final answer there. For the last one, ammonium sulfate. This one's pretty tricky because there's 2 of them. So let's have a look at what the polyatomic chart says. So within the polyatomic chart, we can find ammonium right here, and we can find sulfate right here. So these 2 we need to keep in mind. So ammonium, NH4+, sulfate, SO4, 2 negative. So let's write them out. Ammonium is NH4+, and sulfate is SO4, 2 negative. We're going to cross them, and you're going to be left with NH4 brackets, because we're going to have a 2 coming down here, and those brackets need to be there, otherwise it's NH42, and then we're going to have SO4, and we're done. We don't need brackets around the SO4 because it's just a 1 on the other side of that bracket, so we don't need to do it. We can just drop the brackets and write SO4. Writing formulas involving polyatomic ions. You can apply the rules for writing ionic compound formulas to polyatomic compounds. Just remember to treat the polyatomic as a single unit, and that's what we were just doing. So for example, what's the chemical formula for sodium phosphate? Well, step 1, write the symbol for each ion beginning with the cation, so that's the metal. That would be sodium in this case, and then phosphate. Step 2, write the ionic charge above each and cross them. Put any original subscript in brackets. So that's what we have here, +1 for sodium, -3 for PO4. Step 4, rewrite the formula. Make sure you put brackets around the polyatomic ion if it has gained a new subscript. So in this case, PO4 has not gained a new subscript, it's just 1, so we just write it as Na3, the 3 from the polyatomic phosphate, PO4. Check your understanding. What is the chemical formula for copper 2 nitrate? So I want you to pause the video and answer this question. So how do we write the formula for copper 2 nitrate? Well, let's write them out. So copper is Cu. It says copper 2, so we know it has a charge of +2. And nitrate, if we find it on our chart here, is located right there. So it's NO3 negative. Now we're going to cross them. 2 comes down here, 1 goes that way. And we're going to rewrite. We're going to say Cu, it's just 1, so we just leave it. NO3 bracket 2. And that's our final answer right there. And that concludes our lesson on polyatomic ions.